Okay, very good afternoon to one and all present here. I, Professor Ashwadeep Fuljale, welcomes you all on behalf of the Department of Mechanical Engineering of Tulsiramji Gaikwad Patil College of Engineering and Technology, Nagpur, for the AICT sponsored GATE classes under the Prerna scheme. So today we have today's guest, Professor Vijay Kumar sir. Sir has delivered a lecture on yesterday wherein he described the IC engine and the machine design part. Today he will continue with the same and the remaining portion of the today's topic. So I again welcome Professor Vijay Kumar sir for today's class. Am I audible to you all? Hello? Can you hear my voice? Am I audible
Yes,
to you
sir.
all?
Audible.
Okay, so Professor Vijay Kumar sir has joined today's session. It may be possible some coverage issue may be there, as we have already discussed earlier. So is it audible, Vijay sir? Meanwhile, if the coverage issue is there, I will have a call to Kumbar sir. Okay. Hello, Vijay sir. Can you hear my voice?
Yes, sir. Yes, sir. Hello. Hello. Am I audible?
Okay, sir. So today, very good afternoon, sir.
Thank you, sir. Already I heard all the whatever the thought about today's. I directly start today's lecture.
Okay, sir.
Today we are going to discuss about the design of brakes, as well as design of bearing also, or all details of this bearing. I'm going to just brush up all the things, because already you might be studied all the things as a part of this your GATE curriculum. So whether PPT is visible, presentation is visible.
Yes, sir. Yes, sir.
Okay, okay. So next is today's topic is clutch. You might be aware about this clutch, use of clutch as well as brakes in machinery as well as automotive is concerned. And basic principle of this normally clutch and brakes is the principle of friction, and all the automotive clutches are used are based on this principle of friction. So fundamental difference between clutch and brake is that in case of clutches, clutch is always in engaged position as automotive is concerned. So during engagement, input and output shaft both are rotating. But in case of this brake operation, at initial position, brake knot is always in engaged position. Whenever we require, then and then we are going to apply the brake and to stop the vehicle. So during this after application of brake, input and output shaft both are stationary. But in case of clutches, after application of clutches, both shafts are rotating. Okay, this is a fundamental difference between clutch and brakes. Okay, as introduction is concerned, when a rotating machine is started, it must be accelerated from rest to the desired speed. A clutch is a device used to connect or disconnect a drive components from the prime mover, such as engine or motor. Generally, if vehicle is concerned, the clutch is located in between the transmission system. Uh, uh, since clutch is also part of transmission system, but generally clutch is located between your gearbox and engine, in between this. Okay, so as automotive clutches are concerned, uh, the need of clutch is arises from the relatively high torque requirement to get the vehicle moving, and the low torque output from the internal combustion engine at low levels of rotational speed. So as to improve or so as to increase the torque requirement of the vehicle, there is a necessity of clutch. Transmission of torque higher from engine to other transmission system is a function of this particular clutch. So these all automotive clutches operating on basically friction, principle of friction. The disconnection of engine from the drive enables to engine to speed uploaded to about 1000 rpm, where it generated sufficient torque to drive the transmission. The clutch can be engaged, allowing power to the transmitted to the gearbox, transmission shaft, and wheels. Brake is a device which is used to reduce the control the speed of system or bring it to rest. One more application in automotive, as brake is concerned, if you consider this parking brakes, it will hold the position of the vehicle. So this is the clutch brake. You can see this is a motor. So this is motor, or we can say engine, and the gearbox. And in second diagram, you can see the brake. So there is a motor or engine and connection to the driven machine, and in between there is a brake is there. So, as classification of clutches and brakes are similar device providing a frictional, magnetic, or mechanical connection between the two components. If the one component rotates and another is fixed to a non-rotating plane or reference, the device will function as a brake. And if the both rotates as then is a clutch. That is, we discussed earlier what is the fundamental difference between the clutch and brake. Okay, at the initial condition, or we can say clutch is always in engaged position, but in case of brakes, brake is whenever we are going to apply, the brakes, then and then brake comes in the picture, and at the end of application of brake, the both input and output shaft are stationary. But in case of whenever the clutches are get engaged, input and output shaft both are going to rotate. So this is a fundamental difference between clutch and brake. This is a what about this force, torque, and energy? What exactly means? Because these terms are essential to design analysis of this brake as well as torque. Sorry, clutch. So whenever the speed or direction of motion of a body is changed, there is a force exerted on the body, as we studied in case of this Newton's law of motion and the dynamics of the dynamics part of the your curriculum. Then if the body is rotating, a torque must be applied to the system to speed it up or slow it down. Okay. So as vehicle is concerned, there is a continuous torque requirement is continuously varying due to various resistances offered by the road wheel. So this torque requirement is continuously varying, and with the help of this transmission system, this torque requirement can be fulfilled. And clutch is a very important part of this transmission system, which will transfer whatever the torque developed by this engine towards the other transmission system, and basically towards the wheel, or we can say the contact point between the road wheel and road. So if the speed changes, so does the energy either by addition or absorption. Okay. With the help of this energy, or energy can speed up the vehicle, or we can say energy is utilized to change the speed from lower to higher. So clutch and brake location. Okay. As we know that this torque is equal to ratio of power and angular velocity. In other words, torque is inversely proportional to angular velocity. Or you might be remember that power, we can simply calculate the power is equal to 2 pi nt divided by 60. So this is a power developed by the internal combustion engine. So in that, this power is directly proportional to speed as well as torque. But if you consider, or you can find out or simplify this equation, we will get this torque is inversely proportional to speed. So as we seen, or you might be experienced in case of this first year, when we running or operating vehicle in the first year. So at this particular location, torque requirement of vehicle is greater and speed is less. So first, in case of first year, there is a more torque developed by the engine, and speed is less. Okay, likewise, that is torque is inversely proportional to speed. This implies that that is usually advisable to locate the clutch and brake on the highest speed of the shaft in the system, so that the required torque is minimum. Okay, so when or where to mount this clutch or brake particularly. So you can choose the highest speed of the shaft in the system, so that required torque is a minimum. Size, cost, and response time are lower when the torque is lower. Okay. Next is a friction clutch. You can see the figure, one input shaft and another shaft is the output shaft, and in between this there is a frictional material is there. So there is no separate friction plate shown in this figure, but as the requirement of torque transmission capacity, or there are number of factors like space availability, then the heat dissipation, inertia effect, again coefficient of friction between this whatever the lining material is there and this input and output shaft, number of parameters on which the selection of number of plates will be there, or friction surfaces can be calculated. We will detail going to discuss in our upcoming slides. This is a friction type clutches, and brakes are most common, which works on this principle of friction, as we discussed earlier. Two or more surfaces are pushed together with a normal force to generate a frictional torque. Normally, at least one of the surface is metal, and other high friction material is referred as a lining. So lining having a number of materials that can be utilized as a lining. The frictional contact can occur radially as a for the cylindrical arrangement, or axially as a disc arrangement. Okay. So these clutches may be single plate, multi plate clutch will be there, centrifugal clutch will be there. We are going to discuss. We can see detailed classification of clutch in upcoming slide. The function of frictional clutch or brake surface material is to develop substantial friction force between when a normal force applied. So there is a absorption of some sort of energy whenever whatever the energy can be applied or whatever the force can be applied by the operator. So this energy or you can say the force can be absorbed with the help of this frictional material. Ideally, a material with a high coefficient of friction, constant property, good resistance to wear, and chemical compatibility is required uh, for the proper application or proper utilization of these clutches and brakes. Clutches and brakes transfer or dissipate significant quantity of energy, and their design must be able to absorption and transfer of this heat without damage or to the component parts or to the surrounding. Next is with the exception of the high volume automotive clutches and brakes, engineers rarely need to design clutch or brake from scratch. Okay, these engineers or designers has to select the particular clutch or brakes as per application requirement, and this application requirement depends on the loading characteristics of the systems, then inertia, then on that they select the appropriately sized clutches and brakes and the proper lining material for the specific application as per requirement. So the function of clutch is to permit the connection and disconnection between two shafts. As when or when both are when there is a relative speed in between this input and output shaft. If you see during the starting of the vehicle, to brake, clutch, to change the gear because at the time at the stationary condition of the vehicle, one shaft is rotating. There is only engine is rotating and so as to change or so as to fulfill the initial torque requirement of the vehicle, we have to we have to apply this clutch. So it will disengage the gearbox and engine, and whenever we apply the first gear, then we will slightly slowly remove these clutch so as to engage again engine and engine and gearbox so as to transmit the torque required torque to the wheel. So this is the classification of clutch as per method of engagement, a method of actuation. You can see mechanical, pneumatic, and hydraulic, electrical clutches, magnetic clutches. Again, there is a positive contact, square jaw, spiral jaw, toothed jaw, friction clutches, disc, drum, core clutches, then overrunning clutches, roller, sprague clutches, spring wound. Then magnetic clutches are concerned, magnetic particle, hysteresis, eddy current. Then fluid coupling can be utilized as a torque transmitting media, as a dry fluid and hydraulic. Fluid coupling, or you can say fluid flywheel, can be utilized in a vehicle so as to transfer this particular torque. So, category of these automotive clutches comes under this friction clutches as well as this some fluid clutches. Okay, and all the couplings are undergoes these positive contact types of clutches. And in case of these automotive clutches, this also called as a progressive type, because when we engage the one input shaft to output shaft, we are going to slowly engaging the input and output shaft, because if you slightly or if you suddenly try to engage this input and output shaft, there will be a jerk to the system, and the system will may stop down. You might be experienced during the if you suddenly removes the clutch lever from your hand, there will be a jerk. So we that's why we apply this or we are going to engage this clutch slowly, so as to smoothly transfer torque from one shaft to another shaft. So there are certain requirements of clutches. Necessity of actuation force must not be excessive. That is very is of operation. Then coefficient of friction should be constant and it does not change with the heat. So as the heat increases, there is a chances of reduction of the coefficient of friction, but should not it should not affect on the coefficient of friction. And this property of this clutch is called as anti-fade characteristics of the clutch. So it possesses good anti-fade characteristics. Then the energy converted to heat must be dissipated. Wear must be limited to provide reasonable clutch life. Next is you can see this is the positive contact type of clutch. So teeth or serrations are there for both the shaft, and we are going to connect this directly. So this is a positive contact type of clutch. Then overrunning clutch, you might be seen the freewheel of the bicycle. This is also one type of ratchet and power type of clutch. You can see this is a freewheel type. Again, this is the roller clutch. Clutches engage in the some critical value. Friction elements are forced radially outwards toward and engage against inner radius or a matting cylindrical drum. Common application of centrifugal clutches include chainsaws, overload releases, and go-karts. Okay. So this is what the clutch selection criteria, how to select the clutch and as per the typical application. You can see this is a type of clutch, sprag clutch. It possesses certain characteristics. One-way clutch, profiled element jam against the outer edge to provide the drive, height or capacity. One-way operation, backstop for highs. Then roller type of clutches. One-way clutches, roller ride up ramps and drive by wedging into place. One-way operation will be there in case of this roller clutches. Cone clutches, it operate on the principle of wedge. So free drive for the machine tools is a proper application, or we can say typical application of this clutch plate. This single plate multi-plate clutch again can be utilized for drives as well as machine tool headstock, motorcycles, etc. Clutch is also can be utilized for the certain mopeds and two-wheelers also. Then magnetic clutches having certain characteristics like compact and having low wear characteristics, and that can be utilized for machine tool gearbox as a machine tool gearboxes and numerical control machine. That is in case of this CNC machine. This clutch can be utilized. So as we discussed about this clutch design, clutches are rarely designed from the scratch. So either my existing design is available and it is being modified for a new application for the clutch, and that can be bought in form of specialist manufacturer. In the latter case, the type, size, and the material for the clutch lining must be specified. The required determination of the system characteristics as speed, torque, loading characteristics, and operating temperature. So many of these factors have been lumped into a multiplier. It's called as a service factor. If you see, in case of two-wheeler, there is a multi-plate clutch is there, and multi-plate clutch going to develop a high amount of heat. So there is a weight type of clutch that can be utilized in case of this two-wheeler. But if you see the heavy vehicles, or we can say in the truck, there is a single plate clutch, and this particular location, the space availability is the main concern. And another is the more size of this friction plate with whatever, or we can say clutch plate is in case of this truck, having bigger size as compared to this two-wheeler. And because of whatever the area required, so this heat dissipation is more in case of this truck. So the application is based on this space availability, then coefficient of friction, number of plates are there. We will discuss all these terms in the design equation related to this clutch design. So first important factor is the service factor, on which this design of clutch can be depend. A lining material is typically tested under the steady condition using an electric motor drive. The torque capacity obtained from this test is then derated by the service factor according to particular application, take account by vibration and loading condition. And according to this, we consider the service factor. As we know that this service factor is nothing but factor of safety. So this is a discuss you might be studied in case of this automobile engineering. This is the fundamental components of this disc clutches. You can see this is friction plate having two frictional surface areas. Then use of this helical spring, which will are going to apply certain types of force to hold this particular plate in between this input member. You can say drive member and driven member. Driving member and driven member in between this clutch plate is located. So it will hold the exact position or hold the contact between this driving member and driven member, and then there is actuating mechanism is also part of this overall clutch system is that. You can see this is a spigot bearing which will helps to engage and disengage of the clutch plate. Then you can see this is a engaged position and disengaged position of this disc clutch. This is a engaged position and this is a disengaged position. In this disengaged position, this spring is get compressed, and you can see this is a helical spring. There are various types of spring that can be utilized like diaphragm spring, etc. So as per requirement, in case of diaphragm spring, there is a application equal pressure can be applied throughout the periphery of this clutch plate. But in case of helical spring, this helical spring may be 3 to 4 in a number as per size of this clutch unit. Then this is a multi-plate clutch. So in that particular condition, instead of single plate, you can see there is a two driven discs are there, having four frictional area. You might be seeing this friction plate on both the sides. There is a frictional area, so which will came into contact during the transmission of the torque. So this is the multi-plate clutches, and number of plates are utilized to transfer this torque. You can see this is the seal also. So as to this will develop the more heat. So as to cooling, there may be oil cooled clutches are there. Then disc clutches can consist of single or multiple clutches. Generally, multiple disc clutches enable a greater torque capacity, but are harder to cool. So frictional clutches can be run dry or wet using oil. So wet clutches and dry clutches. Wet clutches means which is used to reduce the temperature with the help of this oil. So typical coefficient of friction is about 0.07 for wet clutches and 0.45 for the dry clutches. These are some certain standard values. While designing, we have to take into consideration of these values. If you see, this is a running clutch bed. While running a wet clutch in an oil, reduces the coefficient of friction. It enhances the heat transfer and the potential for cooling of the components. So, expanded solution for this reduction of this friction coefficient is to use number of discs, hence the multiple disc clutches. Okay, we have to use number of friction clutches. So, torque transmission capacity, there are number of factors on which this torque transmission capacity of this plate will be there. That is, effective radius will be there. Effective radius of this frictional disc. Then F, there is a clamping force is also important factor, and number of frictional surface are these important parameters which affects on the torque transmission capacity. So while designing the clutch, there are certain assumptions are there. So these assumptions are in case of designing of this disc clutch, or we can say generally these clutches are can be designed on the basis of two. One is the uniform pressure theory and uniform wear theory. You might be studied in your machine design course. So if you see, this is a elemental annular ring. In that small r, it is a if you select you select a small area of this friction plate having this thickness delta r, and which is located at the position of small r from the center point of this friction plate. So the elemental area, or you can say this very area of this very small annular section we have selected, or annular ring we can select it, that can be calculated as delta A is equal to 2 pi r into delta r. So the force, or we can say the clamping force capital F is equal to P into A, where P is assumed to uniform interface pressure. So whatever the force applied on this elemental area, or you can say this angular ring, that can be used, that can be utilized. So the force acting on this calculated as a delta F is equal to 2 pi r P into delta r. So if you, now we have to calculate the total area of this frictional surface as well as total force acting on this particular frictional surfaces. So we are going to integrate this both equation, and we get, you see this integration Ri to Ro, in that particular case Ri is the inner radius and Ro is the outer radius of this friction plate. You might be seeing, or you just remember the frictional surface of this friction plate, so you get the clear idea about this. So capital F is nothing but gives the integration Ri to Ro is equal to 2 pi r P into dr. So if you take an integration with respect to this Ri and Ro, we will get the equation 2 pi P into r square divided by 2 and Ri raised to r. So if you simplify this equation, we get F is equal to pi to Ro square minus Ri square. So in that case, particularly, as I told, the F is a clamping force which acts radially towards this particular friction surface, or we can say while designing the clutch, radially acts as this F. F is also necessary force required to clamp the clutch disc together. So the friction torque delta T that can be developed on the elemental ring is the product of elemental normal force by mu into delta F and the radius. So as we know that torque is equal to force into perpendicular distance. So the whatever the torque acting on this elemental area or this annular ring can be calculated as a delta T is equal to R into mu into delta F is equal to 2 into mu into pi into r square into P into delta R. So where mu is the coefficient of friction which models the less than ideal friction contact which occurs between the two surfaces. Then this total torque can be calculated by integrating this particular earlier equation of torque with the Ri to Ro. So we will get the equation integration of Ri to Ro 2 pi 2 mu into pi into r square P into dr is equal to 2 pi P mu r cube divided by 3 Ri to Ro. By simplification, we will get 2 divided by 3 pi into P into mu Ro cube minus Ri cube. So this equation represents the torque capacity of the clutch, which is the single frictional surface area. So if you increases the number of frictional surface area, ultimately there is an increase in number of torque transmission capacity of that particular clutches. Plus, so if you see the torque transmission capacity with an n number of surface, so it can be given as a T is equal to 2 by 3 into pi P into mu into n into Ro cube minus Ri cube. Okay. So substituting for the pressure P gives an equation for torque capacity as a function of axial clamping force. So capital T is equal to 2 by 3 into mu into F into n Ro cube minus Ri cube divided by Ro square minus Ri square. This is the common equation utilized to calculate the maximum torque transmission capacity. So so most important parameters are clamping force also, internal radius, outer radius, as well as number of frictional surface and coefficient of friction between these. So this is what the torque transmission capacity, or what we can say the maximum torque transmission capacity that can be calculated from these clutches. Okay, so important parameter is, or as we earlier discussed, these clutches can be designed on the basis of uniform pressure theory and the uniform wear theory. So if you see the uniform wear theory is concerned, so the equations assume the uniform wear developed below. The wear rate is assumed to be proportional to the product of pressure and velocity. So P into R into R omega, that is a constant. Again, if you see the maximum pressure for a constant angular velocity, the maximum pressure will occur as at the smaller radius. So P max into Ri omega is equal to constant. So eliminating the angular velocity and relationship between the pressure and the function of the radius, that is P into P max into Ri upon R. So you can see this is the dynamic friction coefficient, permissible contact pressure, and temperature limit for various material that can be utilized as a material for the older component, then own material, sintered material, cork, wood, cast iron, paper paste, graphite, and resin. These all the material can be utilized as a frictional material for the clutch operation as well as brake operation. You can see this is between this when it can be utilized as a dry and when it can be utilized as a weight material. So you can see the values can be for this molded component is for the mu dry coefficient of friction for dry operation is about 0.25 to 0.45, and mu oil when that can be utilized as weight clutch it can be 0.06 to 0.1. And this is a P max, maximum pressure can be applied, that is 1.035 to 2.07, and in temperature range you can see the 200 to 260. Okay, as per P max, and as per loading characteristics of that particular application, this material also can be utilized, or which can be based on this coefficient of friction also. So again, axial force can be calculated for uniform wear theory. Is the delta M is equal to 2 pi into PR into delta R. Again, integrating this equation for Ri to Ro, 2 pi P into RdR. Again, by after simplification, we get 2 pi into P into P max into Ri into Ro minus Ri. When this is this or the torque, the elemental torque is given by delta T is equal to mu R into delta F. Then capital T or total torque transmission is given by Ri to Ro 2 pi mu P max Ri RdR is equal to P max mu pi Ri Ro square minus Ri square. By rearranging terms, we get the equation F divided by 2 pi Ri Ro minus Ri. Substituting value, capital T is equal to mu F divided by 2 into Ro plus Ri for number of frictional surfaces increases. On this is what the on the basis of wear theory, uniform wear theory. Capital T is equal to mu into Nf divided by 2 Ro plus Ri. If you see the design equation or maximum torque transmission capacity for both the assumptions, maximum pressure theory and maximum wear theory. So in case of maximum pressure theory, it can be calculated as transmission capacity can be calculated as 2 by 3 mu into Nf into Ro cube minus Ri cube divided by Ro square plus minus Ri square. Okay, and in case of this uniform wear theory, capital T is equal to mu into N into F divided by 2 Ro plus Ri. So the factors associated for this maximum torque transmission capacity or factors affected on this maximum torque transmission capacity of This class can be calculated or can be considered as a coefficient of friction between mu, that is coefficient of friction, then N and F. N is the total number of frictional surface and F is a clamping force. Rho is a internal outer radius and Ri is a internal radius. So maximum torque for any outer radius. How to decide the Ri value or Rho value while designing the clutch? By differentiating with the respect to the Ri and equating the result to the zero, the maximum torque for the outer radius Rho is found to be when Ri is equal to 1 by 3 Rho. This is very useful formula, can be used to set the inner radius of the outer radius is constant to a particular value. Okay, this is very important parameter while selecting a particular design of this particular clutch. If you see, this is a design of clutch. Clutches are usually designed based on the uniform wear theory. The uniform wear assumption gives the lower torque capacity clutch than the uniform pressure assumption. So preliminary design procedure for this clutch design requires the determination of torque and speed, specification of space limitations, selection of material, and selection of principal radii Rho and Ri. Okay, so common practice is to set the value of Ri in between 0.45 Rho to 0.8 Rho. After that, there is a procedure to select. First, you have to determine the service factor. Then determination of required torque capacity is equal to power divided by omega. Then determination of coefficient of friction. Then determine the outer radius Rho and the inner radius Ri and the axial actuation force required. So this is what the standard procedure through which we can just design the or we can select the particular clutch, or we can calculate whatever the parameters related to clutch as per the application requirement. So material is concerned, the material used for clutches is typically grey cast iron or steel clutch plate. The friction surfaces will consist of a lined material which may be molded, woven, sintered, or solid. Molded lining consists of polymeric resin used to bind fibrous material and brass and zinc chips. Because if you consider the requirement of or plus requirement, the inertia is the most important component. Thus, to maintain sufficient inertia, there is a utilization of proper or use of proper material is very important. If you see the example of this clutch design, a clutch is required for a transmission of power between four-cylinder internal combustion engine and a small machine. Determine the radial dimension for a single phase dry clutch with a molded lining which permits the 5 kW power at 1800 rpm. Base the design on the uniform wear theory. So, on the uniform wear assumption, or we can say on the basis of uniform wear theory, we have to design the clutch. Okay, and only single frictional surface area will be there. You can see this is one input shaft. This comes from engine, and this is one is a output shaft which can be which will be from towards this particular machine operation. So we have first step is we have to select the service factor. So from the standard table, we have to select the service factor. Service factor of 2 that should be used. The design will be therefore undertaking using a power 2 into 5 kilowatt to 10 kilowatt. So there is a certain types of reserve strength that can be provided for any design. We generally select the factor of safety as a reserve strength of any design. Okay, so for this we had selected this service factor. So this application is requirement is 5 kilowatt. We are good the design by selecting the service factor is about 10 kilowatt. So if you see the solution, the torque transmission can be calculated as power divided by omega. From this equation, we calculated torque requirement, or we have to transmit this particular torque is about 53 Newton meter. So from the table where material were shown and provision of friction from dry application as well as wet application we had seen. From this table we are going to select the material as well as the coefficient of friction and we selected this coefficient of friction is about the mu is equal to 0.35, and P max maximum applicable pressure is about 1.55 million Newton per meter square. You can see this value we had selected this molded component, and this P max meganewton per meter square. Then next step is calculation of RI. So as we earlier seen that for this particular value we will get the maximum torque transmission capacity of the RI from this plus bit. So RI can be calculated as a under root of 1 by 3 into RO. From this we can write capital T is equal to pi into mu in underscore 1 by 3 RO P max into RO square minus 1 by 3 RO bracket square. So it can be written as a pi into mu into square root 1 by 3 P max RO cube minus 1 by 3 RO cube is equal to pi into mu in bracket 4 by 27 P max RO cube. Okay, after simplification of this equation, we get the value of Ri is equal to 0.024997. Then we have to calculate the clamping force. Clamping force, that is F is equal to 2n Ri P max Ro minus Ri. So in that this clamping force is about 4,443 Newton. So the clutch consists of a disc of inner and outer radius of 25 and 43 mm respectively, with a molded lining having coefficient of friction is about 0.35, and a maximum permissible contact pressure is about 1.55 MPa, and the actuating force is a 4.4 kilonewton. So this is what the best simple example on which this clutch can be designed, or how the procedure, or which procedure, or what are the steps we have to follow for the design of any clutch. So first is we have to select the service factor, and according to of service factor, basically we have to select the material for this friction lining material, as well as coefficient of friction, as well as this P max for this particular application. After that, we have to calculate the value of Ri from the standard equation, that is Ri is equal to in bracket underscore 1 by 3 into Ro. And after that, we have to calculate the value of Ri and Ro. After that, clamping force, inner and outer radius. So this is what the standard procedure, or what we can say steps that can be followed to design any clutch. Okay, in certain requirement, again certain requirement or requirements are there. A space requirement will be there. So heat dissipation will be there. So according to this, we have to decide the number of threads that can be utilized to design the clutch. If you see the brakes, the basic function of brake is to absorb the kinetic energy and dissipate in the form of heat. So, and function of brake is to completely stop the vehicle, or completely stop of the machine, or reduce the speed of that particular machine. Or in case of this automotive, or we can say the vehicle is concerned, we have to maintain the position of the vehicle when vehicle is in the parking condition, or when vehicle is going to park. Okay, that particular time brake has to maintain the position with the help of this parking brakes, or we can say handle. So if you see the example, an idea of magnitude of energy that must be dissipated can be obtained from considering familiar example of car undergoing emergency stop in 7 seconds from 60 mile per hour, that is a 96 kilometer per hour. So a solution is concerned. The car mass can be considered as 1,400 kg, and assuming 65% of car weight is loaded onto the front axle, and during rapid braking, then the load on the front axle can be calculated as 1400 into 0.9 sorry 9.81 into 0.65. So the whatever the loading after braking on the front axle can be calculated is 8927 Newton. After that, if you see uh, the two brakes, there will be shared between the two brakes. So energy must be absorbed by the one brake can be calculated as capital E is equal to 1 by 2 into M into V1 square minus Vf square. So capital E is equal to 1 by 2 in bracket 8927 divided by putting these all these particular values. We get the equation capital E is equal to 161.8 kilojoule. So if the car works uniformly in 7 seconds, then the heat that must be dissipated can be calculated as a 161.8 into 103 by 7 is equal to 23.1 kilowatt. From your experience of heat transfer, say 1 kilowatt domestic heater, you will recognize that this is significant quantity of heat transfer away from the relatively compact components that make up the brake assembly. Okay. So you know that this conventional equation of this heat transfer, the Fourier equation, Q is equal to H delta T. So this equation indicates that the ability of brake is to dissipate the heat generated because as the surface area increases and the heat transfer coefficient of is also rises. For air, the heat transfer coefficient is usually depends on the local flow velocity and the geometry. And method often used for disc brakes to increase both the surface area and the local flow is to machine multiple axle or radial holes of the disc. So if you see the classification of or we can say the types of brakes, so these are methods of according to methods of engagement: mechanical, hydraulic brake, electrical brake, automatic brake. Then friction brakes are concerned, drum brakes, disc brakes. In drum brakes, there will be short shoes, long shoes, band brake. In case of disc brake, caliper disc, full disc. Then magnetic, in magnetic cases, electrically on, electrically off. These are the certain types of brakes, and this is a comparative table of brake performance, how the brake is there, and that can be compared on the maximum operating temperature, brake factor, stability, dryness, dust and dirt, and typical application parameters. So you can see for this various types of brakes. For differential band brake, maximum operating temperature is very low, brake factor is high, and stability is low, unstable but still effective. Dirt and dust uh, uh, is good. Winches, hoist, excavators, tractors is a typical application of this differential band brake. Generally, this differential band brake can be utilized in a tractor application, which is used for agriculture cultural purpose. Again, these basically there are two types of brakes: internal contracting and internal expanding and external contracting type of brakes. So external drum brakes, there is a leading and trailing edges are there. You might be studied this in your braking system of the vehicle or in the machine design subject. Types of brakes: two leading shoes, two trailing shoes, one leading and one trailing shoes, and how there is a performance, how it will works. That can be you might be studied theory part of this particular brake system. So you can see this is a comparative analysis of various brakes. I'm not going to take too much time because of we already have very less time available with us. So this self-energizing brakes can be designed so that once engaged, the actuating force applied to assisted by the braking torque. This kind of brakes is called as a self-energizing brakes and useful for the braking large loads. Okay, self-energizing brake. Uh, in actuating force applied is assisted by the braking torque. And another type is self-locking. So great care must be exercised in the brake design. It is possible and sometimes desirable to design a brake in which once engaged, it will grab and lock up. This is called as the self-locking. So if you see the torque, This is what the disc brakes, familiar from this automotive application, where they can be extensively used for the vehicular application. This is called as externally contracting brake, because there is a disc is there, and whatever the friction pads are there, that can be contracted externally, are going to hold this rotating it stationary so as to stop the vehicle. So typically consists of cast iron discs both bolted to the wheel hub, and this is a sandwich between the two pads actuated by the piston supported in a caliper mounted on the stub shaft. So this is the, you can see this is the torque transmission capacity. Capital T is equal to mu into F into Re, where Re is the effective radius, and you can see the theta is there. Theta is there. Circular pad, and annular pad is there. So clamping force is capital F, and according to size of this, then actuating force can be calculated at capital F is equal to P average into theta rho square minus Ri square divided by 2, or assuming uniform wear by capital F is equal to P max is equal into theta into Ri into Rho minus Ri. The relationship between the average and maximum pressure for the uniform wear assumption is given by P average divided by P max is equal to 2 Ri divided by Rho divided by 1 plus Ri upon Rho. So effective radius can be calculated as Re is equal to 2 by 3 into Rho cube minus Ri cube divided by Rho square minus Ri square. And assuming uniform wear, Re or effective radius of the brake can be calculated as Ri plus Rho divided by 2. This is average of this two radius. This will be effective radius for this by assuming this uniform wear theory. So circular pad disc brake design values, you can see this is some standard values that can be utilized for the designing of the brakes. So for circular pad, the effective radius is given by Re into is equal to R into delta, where the values of delta are given in the table as a function of ratio of pad radius as well as a radial location, that is capital R to small r. So actuating force capital F is equal to pi into R square into P average. If you see the example of this caliper brake design, so caliper brake is required to design for the front wheels of a sports car with the braking capacity of 820 Newton meter for each brake. Preliminary design estimate have set the brake geometry Ri, that's internal radius 100 mm, Rho 160 mm, and theta is 45. Pad with coefficient of friction is 0.35. Has been selected. Determine the required actuating force and average maximum contact pressure. So, as a solution is concerned, if you consider there are two pads, so torque capacity per pad is about 820 divided by 2. So it will be 410 Newton meter. And effective radius can be calculated by using this uniform wear theory. Uniform wear theory, this Re effective radius is the average of these two radiuses, that is Ri and Rho. So this can be calculated as 0.1 plus 0.16 divided by 2 is equal to 0.13 mm. So the actuating force is given by capital F is equal to capital T divided by mu into Ri. So this will be 9.0 double kilometer. Maximum contact pressure can be as can be calculated as or calculated for this particular example is 1.912 meganewton per meter square. So the average pressure can be calculated as P average is equal to P max divided into 2 Ri divided by Rho divided by 1 plus Ri divided by Rho. It can be 1.4 into 471 meganewton per meters. So this is what the design process for simple design of this caliper. I'm not going to discuss all the examples of the design of all the type of brush, but just brush up the things related to other types of brushes, brakes also, like drum brake. You can see this is the drum brake. Drum brake applies the friction, the external or internal circumference of the cylinder. These brakes are generally internal expanding brake. So the drum brakes consist the brake shoe which has the friction material bonded to it and the brake drum. So braking the shoe is force against the drum, developing the friction torque. Drum brakes can be divided into two groups depending on whether the brake shoe is external or internal to the drum. The further classification can be made in terms of length of brake shoe, short, long, and complete band. Okay, then short and long shoe internal drum brake. Short shoe internal brakes are used for centrifugal brakes that engage at a particular critical speed. Then long shoes internal brakes are used principally in automotive application. If you see the calipers whatever used in case of this any vehicle this drum brake, or you can say internal expanding brake. So arc of contact between the brakes is wholly covered the drum, and there will be two caliper are there. So drum brakes can be designed to be self-energizing. So actuating force can be assisted by this braking torque in case of this self-energizing brakes. So once engaged, the friction force increases and normal force non-linearly. So increase in the friction torque positive impact. Stability is concerned, one problem is associated with some drum brakes is the stability, because if the brake has been designed so that the braking torque is not sensitive to small changes to the coefficient of friction, which will occur if the brake is worn or wet, and then brake is said to be stable. As the friction material is considered, if there is increase in heat, there is a change in the coefficient of friction. So it must possess the antipared characteristics like in case of these clutches as well as brake also. So if small change in the coefficient of friction causes a significant change in the braking torque, and brake can be unstable, and that will tend to grab the friction. If the friction coefficient rises, or the braking torque will drop noticeably if the friction coefficient reduces. So stability is most important part of this braking system. If you see, this is a short two external drum brakes are there. This is a theta. You can see this is a pivot at X, then brake lever will be there. Then if the included angle of contact between the brake shoe and the brake drum is less than 45, then the force between the shoe and drum is relatively uniform, and that can be modeled by single concentrated load factor, that is Fn, and it can be written as Fn is equal to max into R theta into W. Then frictional torque or frictional force can be calculated as Ff is equal to mu into Fn, and then torque can be calculated Ff into R, that is a mu into F and into R. And then in case of this short external drum brakes, you can see this is a short external drum brake with the pivot. If you see, if you calculate the movement or reactions, we will get the Rx is equal to minus Ff, and Ry is equal to F minus Fn. One important thing is that the configuration and direction of rotation, uh, mu FLC adds or combines with the actuating force A into Fa. Once the actuating force is applied to the friction generated at the shoe, acts to the increase the torque. This kind of braking action is called as the self-energizing. So short shoe external drum brakes. If the brake direction is reverse and the friction momentum mu Fn into C becomes negative, and applied force Fa must be maintained to generate a braking torque. This combination is called as a self energizing. Then short shoe external drum brakes. Uh, if the brakes is a self-energizing, and if the mu c is less than b, then the force required to actuate the brake is zero or negative, and the brake action is called as the self-locking. If the shoe touches the drum, it will grab and lock. This is usually undesirable, and expectation being hot stops and overrunning clutches type application. Um, Particular application of this. Then, 45 as a if you see, this is a long internal component shown in this diagram. Drum is there. Again, leading shoe is there. Again, trailing shoe is there. Then retracting spring is there. Then you can see this is a hydraulic cylinder, heel shoe. Then anchor pins are there. This total assembly is called as the calipers, and this is what the friction material radially which acts on this particular drum. So, in case of this long shoe internal drum brakes can be activated by the double hydraulic pistons and under which forces the free ends of the brakes. Apart to the non-rotating shoes, comes in the frictional contact with the rotating brake drum. A leading and trailing shoe layout consists of a pair of shoes pivoted at the common anchor point. So depends upon this anchor position. There may be the shoes may be leading or trailing, and the actuating force which will act depends on this leading as well as the trailing shoe. So there may be rate of wear which also depends on the types of brakes, either two trailing, two leading, or one leading and one trailing. So you can see this is a leading shoe. The leading shoe is identified as a shoe whose expander piston moves in the direction of rotation of the drum is called as the leading shoe, and vice versa. This is the trailing shoe. The trailing shoe is the shoe whose expander piston moves in the direction opposed to the rotation of the drum is called as a trailing shoe. This is what one example of this long shoe internal drum brakes. Determine the actuating force and the braking capacity for the double internal long shoe brakes as shown in figure. The lining is sintered material with the coefficient of friction is about 0.32 and the maximum lining pressure is about 1.2 megapascal. The drum radius is about 68 mm and the shoe width is about 55 mm. If you see the solution of this, capital B is equal to 0.7 is equal to 0.05701 meter. As the angles the brake axis are not explicitly shown on first calculated and theta 2 124.7 degree. As theta 2 is greater than 90 degree, the maximum value of sin theta is 1. Sin 90 is equal to 1. For right hand shoe, this Mn can be calculated as you can see 0.25 into 0.068 into 0.0571 into 1.2 into 10 raised to 6 divided by 0.745 into 2 W divided by 3 raised to 9 2.4 minus sin 9.45. So after simplification, we will get the value of Mn is equal to 153.8. Then mm 57.1 Newton meter. Then from this equation we calculated as a actuating force F is equal to Mn minus Mf is equal divided by A. This is a 938.9. Then torque applied by the right hand shoe is given by T right shoe is equal to mu into W R square P max divided by sin theta into cos theta 1 minus cos theta 2. After calculation, we will get the value of T right shoe is equal to 69.54. And the torque applied by the left hand shoe cannot be determined until the maximum operating pressure P max for the left hand shoes has been calculated. So for this left hand, you can see value of Mn and value of Mn and Mf. So and after that value of Fa is actuating force that can be calculated as 938.9. So after simplification, we can calculate value of P max is equal to 0.5502. And torque transmitted by this left shoe can be calculated with the help of this equation mu to omega mu to W to R square P max divided by sin theta P max into cos theta 1 minus cos theta 2, and it can be calculated as 31.89. Newton meter. So total torque can be applied. T is equal to T total is equal to T right shoe plus T left shoe, and this is a 101.4 Newton meter. So if you see again this band brake, one of the simplest type of braking device is band brake. This consists of flexible metal band lined with the friction material wrapped up partly around the drum. So the brake is actuated by the pulling the band against the drum. This is the band brake. I'm not going to discuss all these things because time is very less. So if you see the part of conclusion is that clutches are designed to permit the smooth gradual engagement or disengagement of the prime mover from the driven load. Then brakes are designed to de-accelerate a system. Clutches and brakes are similar device providing frictional magnetic or direct positive connection between the two components. This selection has concentrated on rotating clutches and brakes and specifically on the design of friction-based devices. Again, detailed design of clutch braking system involves the integration of a wide range of the skills such as the bearing, shaft, splines, teeth, flywheel, casings, frictional surfaces, hydraulics, sensors, and control algorithms. Both the brakes and clutches can be purchased from the specialist supplier or alternatively key components such as the brake pads or clutch discs can be specified and brought in the in form of specialist suppliers and integrated into the fit to purpose the machine design. So this is what about the clutch and brake design. So common working principle of this clutch as well as brakes are is a friction. Working principle is friction, or we can say these both are working on the principle of friction. So now we are moving towards the bearing part of next part is bearing. What is bearing? Bearing is a machine element which support another moving machine, that is a machine element called as a journal. So it permits the relative motion between the contact surface of the members and while carrying the load. I am not going to discuss too much because you might be aware about all these things. You might be studied in machine design. This all the parts. Why do need them? First, to reduce the friction, carry load, and again guiding the moving parts. So you can see this is a particular application of the bearing. If you use the bearing, there is a rolling friction, or you can say use of rolling bearing that can be used to reduce the effort also. This is the sectional view of the bearing, roller bearing. You can see this is the component. These are the components: outside diameter, bore, and rolling element bar, inner race, outer race of the bearing, and retainer cage is there. Then this is what the components of the various components of the bearing: seal, again outer ring, then a rolling element, cage, inner ring, seal, etc. Again, if you see the properties of sliding contact bearings, material are compressive strength, fatigue strength, comfortability, embeddability, bondability, corrosion resistance, thermal conductivity. Again, thermal expansion is there. Then various as material is concerned, diabet material, bronzes, cast iron, silver, non-metallic material, soft rubber bearings, wood bearings. Then this is what the material and their properties. Properties of this bearing material: tin-based bearing, lead-based babbitt, lead bronze, copper lead, aluminum, silver, silver lead deposited. Again, this fatigue strength, comfortability, embeddability, and discovery characteristics, corrosion resistance, thermal conductivity. Uh, so according to this, we have to choose the bearing material. So properties of lubricant are concerned: viscosity, oiliness, density, index, flash point, fire point, then pour point or freezing point. Then as lubricants utilized for this bearing are liquid oil, then semi-liquid greases, and solid. As a classification of the bearings are radial bearing and thrust bearing. Again, depending upon the nature of contact, sliding contact and rolling contact bearing. Again, these are the types of bearings: plain bearing, rolling element, or anti-friction bearing. Again, on the basis of this area of contact, journal bearing, then guide bearing, then thrust bearing or tilting pad, axial pad. Again, journal bearing can be classified as a solid, lead bearing, half bearing, tilting pad, then cylinder and rider ring, etc. You can see this is a ball bearing, then spherical roller, then spherical roller, asymmetrical, the cylindrical roller, needle roller, taper roller bearing. That can be utilized in a bearing. If you see, this is in case of this point contact and line contact is there. So in case of this point contact, less area of contact, less friction, more speed and less load. So in case of line contact, more area of contact, more friction, less speed and more load. So you see the plain bearings, it is also called as a bushing, journal bearing or sleeve bearing or rifle bearing. So anti-friction bearing is concerned, ball bearing, radial ball bearing, angular contact ball bearing, roller bearing, cylindrical roller bearing, taper roller bearing, spherical roller bearing, needle roller bearing. Then forces acting on the bearing axial and radial load, and combination of these both axial and radial. You will see this is a thrust force, and this is a radial force acting on this bearing, and combination of this is in this diagram. So you see this is a radial and thrust load acting on this bearing. So in case of this pure radial load, and if you see this is a thrust load, part of load can be taken by this ball, and this part of this load that can be taken radial. So some more is a dual bearing in which the load is carried by rolling the axial slightly off center. Fluid bearing in which the load is carried out by the gas or liquid. In case of this magnetic bearing in which the load is carried by magnetic field. Then flexure bearing in which the motion is supported by the load element on which it depends. Then roller bearing, radial, cylindrical and radial tapered bearing. This is what the needle bearing. If you see the types of sliding contact bearings, there are guide bearing, sliding contact bearing in which the slide action is guided in a straight line and carrying radial loads may be called as a slipper or guide bearing. Example, it can cross head or of steam engine. Then this is a journal or sleeve bearing. You can see this is various components. Then partial journal bearing. Then fitted bearing. Then classification on the lubricating systems, hydrodynamics and bonded lubricated bearing. Hydrodynamic lubricated bearings, load carrying ability of the hydrodynamic bearing arises simply because of viscous fluid trains being pushed around. So, on the basis of load carrying capacity, base film lubrication and squeeze film lubrication. If you see this, when it is this base film journal bearing at rest, slow speed and high speed. In certain cases, the bearing oscillated or rotates so slowly that the base film cannot provide the satisfactory film thickness. If the load is uniform or varying in the magnitude while acting in a constant direction, this becomes a thin film or positive zero film problem. But if the load reverses its direction, the squeeze film may develop sufficient capacity to carry the dynamic loads without contact between the journals and the bearing. Such a bearing is called as a squeeze film bearing. So journal bearing types are journal bearing types of split journal bearing, again half bearing, tilting pad bearing. If you see this is the number of pads are there. 3 pads are there. Sorry, 4 pads are shown in this figure. Then guide vertical fan thrust bearing. Can be bearing of same size and so you might be aware about this real lab of the bearing. It is 10% of the Just L10 life is a 10% of life being tested at a phase before rated number of revolutions of the inner race at the rated speed. Again, this nomenclature is concerned. Radial clearance is there, axial clearance is there. Again, you can see in this normal clearance and reduced clearance because of lighting, and increased clearance due to temperature. This is what the bearing description: size, diameter, gauge, seal or shield, ring modification, clearance, grease, then angular contact bearing, series, size, bore diameter, contact angle, duplex gauge, and duplex arrangement. According to this sort of bearing designation. Then this is the tolerance. Normal bearing, precision bearing, and high precision bearing. So how you can see how the tolerance it will vary. So if you see the design consideration of these bearings are concerned, first we have to determine the ratio L by D. Then checking the bearing pressure is near about W divided by L into D. Then assume the lubricant forms stable of operating temperature T0. This temperature should be between 26.5 degrees Celsius and 60 degrees with the 82 degrees Celsius as the maximum for high temperature installation, such as steam turbine. Determine the operating values of Zn divided by P, that is Sommerfeld number, for the assumed bearing temperature, and check this value with the corresponding value in table, so as to determine the possibility of maintaining the fluid film operation, that is Z into D divided Zn divided by P into D by C square, nearly about 14.58 into 10. Then assume the clearance ratio C by D from the table. Then determine the coefficient of friction by using the relation mu is equal to 33 divided by 10 raised to 8 Zn divided by P into D by C plus K. Determine the heat generated by using the relation Qc is nearly about mu into V into W. Then determine the heat dissipation by using the relation heat coefficient Qd is equal to C into A into Tb minus Ta. Then determine the thermal equilibrium to see what the heat is dissipated becomes at least equal to the heat generated. In case the heat generated is more than the heat dissipated, then either bearing is redesigned or artificially cooled by water, and the temperature of bearing is approximately midway between the temperature of atmosphere and temperature of oil. That can be calculated as a Tv minus T is nearly about 1 by 2 into T0 minus T. If you see the same design of the bearing, for well-designed bearing, the temperature of the oil film should not be more than the 60 degree. Otherwise, the viscosity of oil decreases rapidly, and the operation of bearing is found to be suffer. So, temperature of this oil film is often called as the operating temperature of the bearing. In case of temperature of the oil film is higher, then the bearing is cooled by circulating water through coils with bearing. The mass of the oil to remove the heat generated at the bearing may be obtained by dissipating the heat generated to the heat taken away by the oil. M is the mass of oil. Then S is the specific heat of oil. That is the T is the temperature difference between inlet and outlet temperature of oil. That can be calculated as Q is equal to MS into delta T. If you see this is a machinery, then bearing, maximum bearing pressure will be there, absolute velocity. Then this is Zn divided by P ratio, this is C by D ratio, and L by D. From this table, we can see that the value, particular value for the particular application requirement. Thank you. This is from my side. Hello. Hello.